Hey everybody, today we're going to talk about water and all the properties that make it so important for life and living things. So the big thing on water is it is a polar covalent bond. So with a polar bond, that means this covalent bond is an uneven share. So we kind of talked about that a little bit. And so that uneven share, oxygen's a way bigger and way more electronegative. So it's going to take that electron more of the time and therefore make this a negatively charged end. So since hydrogen doesn't get to share the electrons very often, these are going to be a positive charged end. And this is going to be every water molecule is like that. So in between the water molecules, then, that is going to be the hydrogen bond. So that's a pretty strong little bond that helps glue this water molecule to this water molecule. And because of that, we have properties like cohesion and adhesion. So cohesion is going to be the attraction between molecules that are the same. So like water on water. Adhesion is going to be the attraction between different molecules. So like water on glass. And with this hydrogen bonding being a pretty good little bond, then that's going to allow these water molecules to stick together. And so that gives surface tension. So surface tension is when we have molecules on the surface of a liquid that are right next to each other. And they're glued together with that hydrogen bonding, cohesion. And we can take something and set it on top of it that normally might not float in the liquid, but because it just doesn't break that bond, it can float. So this is what we have in like a paper clip or in a water bug. They should be sinking, but they're not because of surface tension. Another interesting little thing, especially for plants, is capillary action. So this is the ability of water to rise up a thin tube. And so that is particularly useful in plants to get the water and minerals from the roots up into the leaf part where the photosynthesis would take place. You and I have a heart that allows us to pump blood against gravity, but a tree would not have a heart, and so therefore it has to rely on capillary action as part of the mechanism to help take that water up above to where the photosynthesis would take place. So some more interesting properties that help make water so valuable for life is the fact that it has a high specific heat. And so what specific heat is, it means that a substance is going to heat up or cool down slowly. Something with a low specific heat would heat up or cool down quickly. So metals have a low specific heat. They heat up very quick, but then they slow down very quickly. Whereas water, it takes a while to heat it up and it takes a while to cool it down. So the specific heat of water is 1 calorie per gram degree Celsius. And that is useful because then living things that are mostly made of water, 70% or more, will not have these crazy temperature fluctuations. So they'll be able to maintain their temperature a little bit better than if water had a low specific heat. Another thing is, when we talk about something's temperature, this is its average kinetic energy. So this would be the average of all the molecules' kinetic energy in that material. So when we want to cool something's temperature down, like in the case of evaporative cooling, what we're doing is losing the hot molecules. So for evaporative cooling, the hot water molecules will turn into a gas through evaporation, and that leaves the cooler ones left to bring the average down. It'd be like if we were talking about the average height in a class, and then we took the 3 tallest people out. That average height is now going to be lower, and that's because the 3 tall people have been removed. So same thing with evaporative cooling. When we lose the hot molecules to evaporation, what's left, the average will be cooler, and the temperature then will be cooler. Another interesting property has to do with water's density. So typically, something's liquid is going to be less dense than the solid. So a material that is a solid is going to be more dense than if that was melted and turned into a liquid. So the density of liquid water is 1 gram per milliliter. Whereas we would think then maybe the ice, since it's solid, should be more than that, but the density of ice would be 0.917 grams per milliliter. And we can see that when ice forms a solid, there's this hexagonal area that has a lot of space, a lot of open space, and so it actually becomes less dense. Now this density then helps ice to float. So here we'd have ice floating in water. Here it'd be like alcohol, which has a density of 0.79, and so the ice is going to be more dense and it would sink. But in the case of ponds and lakes and water ecosystems, then this is very valuable. The most dense water is pretty normal, other than this kind of 0 to 4 degrees Celsius range is when it becomes abnormal. But typically, when something gets hotter, it becomes less dense. And then when something gets cooler, it becomes more dense. So let's say we have 10 degrees Celsius water in our pond, and then a cold spell comes through, and the outside air is -2 degrees Celsius. So that's going to cool this water down. Once it hits 4 degrees, that's the most dense water is ever, and so it will cause it to sink. And then whatever was at the bottom gets pushed up and is now exposed to the -2 air, and so it's going to cool down until it gets 4 degrees as well. And this is just going to keep happening and happening until the entire pond is 4 degrees. It has nowhere to go, and then at that point it can get cooler, 3, 2, 1, 0, and then it will freeze. And so because of this interesting thing, water will freeze from the top down, and we'll get those layers of ice on the top, as opposed to if it acted normally, it would freeze from the bottom up and would be way more likely than to freeze solid, which would not be good for the aquatic ecosystem of that pond or lake. Another interesting thing about water is its solvent capability. So oftentimes we call water the universal solvent, or the solvent of life. And so some terminology. So when we have a solution, this is when we have 2 or more substances where one thing is dissolved in another. What's doing the dissolving is the solvent, and then the substance that's being dissolved is the solute. So in the case of salt water, our water molecules would be the solvent, and then the salt would be the solute. Okay, and so water is really good because that polar molecule of water has the ability to dissolve a lot of ionic things, and it also has the ability to dissolve a lot of covalent things as well. Now, there are some things that are too nonpolar, like oil, that would not dissolve with water. And so that's why we have sayings like oil and water don't mix. So typically, likes dissolve likes, and so covalent things dissolve covalent things, and then polar things would dissolve polar, and nonpolar would dissolve nonpolar. So, but water is very good at doing a little bit of everything as long as we're not too nonpolar. And then one last useful thing for water is when we make a solution that has hydrogen or hydroxide ions. These are what we would call acids and bases. And so the pH scale measures the acidity of a solution. So our pH scale is 7 in the middle, and it goes down to the acid side of 0 and up to the base side of 14. So when we're in the middle, that means we're neutral. And so we can see some common acids, so lemon juice, gastric juice, grapefruit, soft drinks, tomatoes, urine. These would all be acidic type solutions. Whereas basic, so like human blood, salt water, milk, magnesia, many types of cleaners, those would be basic solutions. And so typically living things, we don't want a big change there. And so we try and keep things buffered is the term. And so this helps resist the change in pH. And so a buffer consists of 2 things usually. It consists of a weak acid and then a salt of that same acid. And so if we get more hydrogen ions in the solution that would want to lower the pH, making it more acidic, then the salt of that weak acid will help counteract those and keep those neutralized. If we get exposed to more hydroxide ions, and then that would intend to raise our pH, the weak acid can help neutralize those. And so this helps us just kind of stay at the desired pH that we would want to be at. So those are some of the things that make water pretty special. And that's a good thing because all living things need and are made of a lot of water. So I hope that was helpful.